This is part two of the chemistry chapter 2, and we left off here. This is the next slide after the one that we left off with in the first lecture. What you're looking at here is the electron shells of two different atoms. The first one is carbon, picture A, and then picture B is neon. Um, and we can get some information from looking at these pictures as long as we can make a correct count of the protons. So in fact, we're going to cheat a little bit because I told you the number of electrons will equal the number of protons. So in carbon, we have 1, 2, 3, 4, 5, 6 electrons, and we can't see all 6 protons, but we can assume that there are 6 protons. So we know that carbon has 6 electrons and 6 protons. So the atomic number for carbon is going to be 6. And mainly what these images are trying to show you is which energy levels the electrons will fill. The first two electrons will fill the first energy level because it is filled with 2. And then the second energy level, there's only 4 left out of 6. So those 4 will fill the second energy level. Although it takes 8 to fill the second energy level, we only have 6 total electrons. Now let's look at neon. Neon has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Neon is a noble gas, which is in group 8 of the periodic table. Noble gases are already stable because their outer shells are filled, and the outer shell for neon is the second energy level, and as you can see, it is filled with 8 electrons. So that makes it chemically stable. There are 2 in the first energy level, there are 8 in the second. That makes neon chemically stable, and it will not interact with other atoms and form chemical bonds. Checkpoint define atom, smallest unit of an element, um, which is an element is the simplest type of particle or substance. Question number 2, how is it possible for 2 samples of hydrogen to contain the same number of atoms but have different weights? Because there are isotopes. Each element has different isotopes. Hydrogen has hydrogen 1, hydrogen 2, and hydrogen 3. Um, these are the mass numbers of the isotopes of hydrogen. So, and by the way, their names are tritium, deuterium, and oh gosh, how did I forget the first one? There's the isotope of the most common stable isotope of hydrogen, and then there is deuterium and tritium. I can't believe it's been a long time since I actually have taught chemistry. So anyway, let's move on though, because I don't want to give you too many lectures to have to watch. Chemical bonding, that's our next topic. Chemical bonds are not like glue, they are attractions. They are very strong attractions that atoms have with each other, and they interact with each other in order to become more stable. Most atoms are more stable when they form a bond with another atom. And how they bond is they either share electrons with another atom, or the atoms in the bond gain or lose electrons. So the ones that lose the electrons transfer their electrons to the atoms that gain electrons. So chemical bonds hold atoms together after the reaction has ended, and they hold atoms together in a very strong chemical attraction. Chemical bonding forms molecules and compounds. There is a slight difference in the definition of molecule and compound, although I'm not going to be really picky about it, but just so that you know, molecules contain more than one atom bonded together by shared electrons. More than one atom bonded together by shared electrons. An example of a molecule is H2O, which is water, and that is two atoms of hydrogen bonded with one atom of oxygen. But O2 is the molecule of oxygen gas, like we breathe in to our lungs, and it's basically one oxygen atom chemically bonded by a double bond to another oxygen atom. So in other words, in molecules, the two different atoms don't have to be different types of atoms. You can have two of the same atoms chemically bonded together. But in compounds, the atoms that are bonded together must be different. They must be from different elements. So oxygen gas, O2, cannot be called a compound, but water can. Water can be called a compound because it has the two different elements, hydrogen and oxygen, and this is the chemical compound for glucose. This is a good one to memorize. Contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So the compounds, just the atoms that are bonded must be from different elements, whereas molecules, all compounds are molecules. All compounds are also molecules, but some molecules would not be classified as a compound, like oxygen is not a compound. Now, we talked about isotopes. These are atoms that have different numbers of neutrons. Now we're going to talk about ions. And these are atoms that have a charge. They have an electrical charge. That means that they have lost or gained electrons. So an ion is an atom with an electrical charge. A cation is an ion with a positive charge. And these ions form when atoms lose electrons. Because, for example, I'll give you an example, sodium. The sodium atom has 11 protons, 11 positive charges, and 11 electrons, 11 negative charges. Sodium tends to lose one electron, giving it 10 electrons to in order to become stable. So sodium will end up with 11 protons, 11 positive charges, and 10 electrons because it does tend to lose one electron in order to become chemically stable. And that will give it an extra positive charge. So the way that we write that is Na, that's the symbol for sodium, and then we just put a plus because it has a positive charge. Some atoms will gain electrons, and since electrons are negatively charged, that gives the ion that forms a negative charge. An anion is an ion with a negative charge. Ionic bonds form between cations and anions. And a good example is when sodium ions, which are positively charged, are attracted to chloride ions, which are negatively charged, and they form the ionic compound sodium chloride. And this happens because opposite charges are attracted to each other. And here is an illustration of how the chemical bond forms. Sodium again has 11 electrons in the atomic form. When it's an atom, when we call it sodium atom, it has 11 electrons. But it's got this one electron in its outer energy level, and if it just will lose that electron, then its outer energy level will now become energy level number 2, which will be chemically stable because it is filled with 8 electrons, following our octet rule. So that's what happens. Sodium loses one electron, and chlorine has 1, 2, 3, 4, 5, 6, 7 electrons in its outer energy level. So if it gains an electron, it will become chemically stable with 8. So that's what happens. Sodium tends to lose an electron, giving it a positive charge. It will transfer that electron to a chlorine, making it a chloride ion with a negative charge. And then those two ions, the sodium cation and the chloride anion, are attracted to each other because opposites attract. This is ionic bonding. Covalent bonding is a little different. Covalent bonds are formed when, instead of one atom transferring an electron to another, they share electrons. This results in the strongest chemical bond, is when atoms actually share electrons. A single covalent bond is represented by a single line. That means one pair of electrons is being shared. That happens in hydrogen. Oxygen, O2, oxygen gas, shares two pairs of electrons. So you would use two lines, which is called a double covalent bond. And then carbon dioxide, the carbon forms four covalent bonds, two with one of the oxygens and two with the other oxygen. So it's got two double bonds in carbon dioxide. Now, covalent bonds can be classified as nonpolar or polar. And this is going to be very important in their chemical properties and the characteristics of these molecules. So when the electrons are shared equally, and all of these examples, hydrogen gas, oxygen gas, carbon dioxide, the electrons that are shared between atoms are shared equally. When they are shared equally between atoms, we call those nonpolar. But sometimes one of the atoms that forms the covalent bond has a stronger pull or a stronger attraction to the electrons that are being shared. And so one end of the molecule will have a slightly negative charge, the end that has a stronger pull on the electrons. And the other end will have a slightly positive charge. And that will cause it not to be an ionic bond, but it will cause it to be a polar covalent bond. A water molecule is an example of this. What happens with a water molecule is you have an oxygen that is single covalently bonded to two hydrogen atoms, and the oxygen has a stronger pull on the electrons, so we give it this little symbol, this little delta symbol, and we say that it's slightly negative on the oxygen end and that the hydrogen end is slightly positive because its attraction for those electrons that are being shared, hydrogen and oxygen are sharing two electrons. That's what these bonds represent. So the hydrogen is slightly positive, the oxygen slightly negative. And what happens is if you have a lot of water molecules together, say in a water droplet, the way that the water molecules will arrange themselves is the positive hydrogen ends of the water molecules will face the negative oxygen ends. And the bond that forms between the hydrogen end of one molecule and the oxygen end of another molecule is called a hydrogen bond. What results from hydrogen bonding is a lot of different properties, but surface tension is one. Surface tension allows some insects to walk across the surface of the water because of the surface tension. And that's the only one that's listed. So I'll go on to the checkpoint questions. Define chemical bond. Remember, it is a strong attraction between atoms. There's ionic bonds, there's covalent bonds, and then there are hydrogen bonds, which are not really bonds between atoms, they are bonds between molecules. And the hydrogen bonds are the weakest chemical bonds. Oxygen and neon are both gases at room temperature. Oxygen combines with other elements easily because it is unstable, because its outer energy level does not have 8